Okay, yes, you can see my slides already. All right, I'm praising these two people. Oh, I forgot to copy and paste the name. All right, Javier and Bernardo. Only Javier and Bernardo has submitted the answers to me. The rest, what happened? No answers submitted to me. I only have answers from Bernardo and Javier. The rest, what happened? Too busy to do. So you see my star, okay, I add in the name. I forgot to type it in. All right, so Javier and Bernardo. Well done. Right. Oh, Zeyu, you went, you submitted. When do you submit? Oh, J, sorry about that. Jay. Javier. All right, when do you submit? This morning? But I only downloaded the report like few minutes before the lesson. Okay, did you click submit? You check, maybe you do, you forgot to click submit at the bottom. Okay, then that's strange. All right, doesn't matter. Then we'll see. I can try downloading the report right now. Let me see if I have it. Okay, yes, I have your answers already. Okay, yes, I can see yours. You already submitted, really very close. It will help me if you submit earlier, all right? So you see, for me to download, I need time to prepare the file also, all right? Okay, let's take a look at the MCQ. Oh, Sherman is here. Let me put him in. Okay, hi, Sherman. All right, let me mark your attendance first, Sherman. Right, so we are only missing Natalie. Okay, we can start. Right. Right, so towards the end of this topic, I would like you all to fill in this and tell me which topics you need help in. Okay, we can do this at the end. All right, so we'll go straight to the question. Now, which statement best describes the potential difference? Anyone? Okay, for this one, let me look at the Excel file report. Okay, oh, I must have the one with 3 names. So I have 2 Excel file. Okay, hang on. All right, so now I have 2 different files. Okay, all of you, those who are submitted, you got the correct answer. Then the rest who did not do your work, can you type into the chat what's your answer? What is the definition of potential difference? Jocelyn, Caitlin, Sherman, Zeyu, I don't have, Zeyu have, sorry. Sherman, Caitlin, Jocelyn. 3 of you did not submit your work. Can you put your answer into the chat? What is your answer for this question? What is the definition of potential difference? Not sure, just type not sure. All right, so what's your answer for question 1? Still waiting for Justin, Caitlin, Sherman. All right, so not sure. Thank you for letting me know you're not sure. All right, so that I can go a bit more in detail. It will help me a lot to support you better. Now, potential difference, right? Another word is voltage. It's the same. Just like my child is called Jolene, blah, 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 blah. All right, I call her Jo at home. 2 names. You all have nickname. Your parents will give you a nickname, right? So same thing. Potential difference, another nickname is voltage. It's the same thing. All right, potential difference, another name for it is voltage. And it simply means how much energy is needed to move 1 unit of charge. All right, 1 unit of the charge from one place to another place, from one point to another point. All right, so it's imagine how much energy you need to push. Imagine, give you an energy like pushing an elephant. All right, pushing an elephant from the bedroom to the toilet. All right, to take a bath, and compared to pushing a little Mickey Mouse, a rat. All right, elephant will be harder to push, right? To push from the bedroom to the toilet. A rat is so tiny, it's easier to push the rat from the bedroom to the toilet. Maybe elephant doesn't like to bathe, right? So you require a lot of energy to push that big fat elephant. All right, that one elephant to push elephant from the bedroom to the toilet be harder. All right, so that's potential difference. All right, so potential difference, how much energy is needed to move 1 charge, right? To move 1 unit of charge. Okay, now take note, we use the word charge. We do not use the word electron. It is true that when electric current is flowing, when you have a current flowing, current is made up of electrons. So electrons are moving inside the wire. All right, electrons are moving inside the wire. However, for definition, we do not use the word electron. Instead, here we use the word charge because it could be ions. Here can mean electron. All right, or it could mean positive ion, which is not the electron, or it could mean negative ion. All right, so all these have charges. All right, electron is short form, we write negative E minus because electron is negative charge. That's why we use the word charge. If charge can mean electron, charge can mean ion. Okay. Let me see. Okay, Natalie is here. Okay, hi Natalie. Right, so the answer is A. Now let's take a look at B. All right, rate. Everybody type into the chat, what is rate? Okay, good job, Caitlin and Jocelyn. Your answer is correct. The rest of you, what is the meaning of rate? No worries, Natalie. All right, so what is rate? Starting with S. This one you must know. What is rate? Starting with S, 5-letter word. It is about how fast or how slow, speed. So please know rate equals to speed. All right. So rate is speed. Good job, sir. Caitlin and Jocelyn. Okay, rate equals to speed. Okay, so how fast the charge can move, that is current. It's not potential difference. All right, so here we are talking about potential difference. Potential difference is this one. So the answer is A. All right, if you're talking about statement B, that is current. Now, how about C? C is a ratio of current to the voltage. What they mean is, this one is actually wrong. In fact, it will be, there's no such formula. It should be ratio of voltage to current. It means voltage is on top, divided by, over means divide. Do you see it looks like divide? All right, it looks like a divide, right? Divide by current below. So voltage number divide by current. Anybody can tell me what is this? Anyone? What am I measuring? If I take the voltage, I divide by the current, what am I measuring? That starts with R. Anyone? It's about current, right? Yes, good job, Javier. The rest, what is that R word? It's on the electricity topic. Have you all learned electricity? All right, good job, Zeri. Resistance. Right, so this is the formula. Short form, we will write V over I, that is R. Right, so this is the formula. Okay, so ratio means something divided by something, ratio. All right, in this case is voltage divided by current. That will give you resistance answer. All right, so do y'all still remember our triangle? So this is our little triangle. They put a capital T. All right, so the memory aid is video is real, right? I think last week somebody contributed voting is required. Okay, so video, always start from the top. Video is real. So if you want to find R, you will circle the R, or you use your finger and cover up R. If you use your finger to cover up the letter R, you will be left V on top, I below. That's how you get this answer. All right, so cover up R. If you want to find R, you cover it up. So V divided by I. V on top, I below. This is what it means. V divided by I. That will give you resistance. So resistance is the ratio of voltage to current. All right, so this is what it means. So this word is resistance. Then this word is current. Okay, this word is potential difference. Or you say voltage. Right, so C is definitely wrong nonsense. You cancel it out. Any questions so far? Okay, so usually I will go through some basics on the topic since it's related to the question here. So I have put everything into one slide to help you. So current, potential difference, another name for it is voltage, resistance, power. All right, so current is how fast the charge flow. So take note, we use charge. All right, so don't use electron, use charge. Okay, so in other words, is how many charges are flowing in 1 second. Because rate is speed, right? Speed is care about time. All right. Rate means speed. So since you're talking about speed, it must have a time. So in 1 second, how many charges are flowing inside the wire? That is current. So if you have a big current, a very big number for current, that means got many charges flowing in 1 second. There are many charges flowing inside the wire in 1 second. Then what is potential difference of voltage? All right, short form we use PD, but no short form for exam. All right, so PD and voltage, it means how much energy is needed to drive, to push 1 unit of charge from one place to another place. All right, so imagine this is the battery. So you see this person is pushing the charge out of the battery, push the charge out of the battery from this point to go back to this point. So how much energy needed? This person needs to use how much energy to push the charge, to move the charge from one point to another point. That is the potential difference of voltage. Okay, so if you have a high voltage, it means there's a lot of energy needed to push that one unit of charge from one point to another point. All right, 1 unit of charge. Now, resistance is a ratio. Ratio, I already told you, it means something divided by something. So in this case, it's potential difference divided by current, which I wrote just now for you. So R equals V over I. Okay, so this is voltage, right, divided by current. Right, so that will give you the resistance. Okay, then what is power? Power is, all right, how much energy is transferred in 1 second? All right, in 1 second, how much energy is transferred? Or how much work is done in 1 second? All right, so imagine if you are a high power student, in 1 second, you can do a lot of work done. All right, how much homework you do in 1 day? But in this case, instead of in 1 day, it's 1 second. How much work is done in 1 second? That's power. All right, so all these please commit to your memory. These are all the definitions for electricity topic. Okay, now we have been talking about 1 unit of charge. So what is that 1 unit of charge? Now 1 unit of charge, you will learn in set 3 and set 4. The unit is called coulomb. All right, so 1 coulomb of charge means 1 unit. You don't need to learn the name coulomb at set 1, set 2 level, but you can just write 1 unit of charge. So what is 1 unit of charge? It doesn't mean 1 charge. It actually means 6 by 24 times 10 to the power 18. So it is a lot of electrons, right? A very big number. Okay, so it is this number 624. Then there's many zeros. All right, so here will be 16 zeros. So this is the charges. All right, I can write the charges. Okay, or I don't use the word electron, I use charges then. Because charges can be electron, charges can be ions. So 1 unit of charge is a lot of the charge. All right, it's a very big number. I just call it 1 unit or 1 coulomb of charge. All right, now if you have potential difference of cell or the battery, cell means battery, I can also have potential difference of the bulb. Okay, so how do you measure potential difference? If you want to measure potential difference of the battery or cell, you put a voltmeter across the battery or across the cell. If you want to measure potential difference of the light bulb, you connect the voltmeter across the light bulb. All right, so this is the light bulb this way. So the voltmeter reading will tell you what is the potential difference of this bulb. So what is the meaning of potential difference? We talk about, it means how much energy needed to push or to drive 1 unit of charge through the component from one place to another place. Another way to think of potential difference is how much energy, how many joules of energy is converted from electrical energy into light and heat for each unit of charge passing through the bulb. All right, so for so many charges, so many electrons passing through the light bulb, how much electrical energy is converted to light and heat energy. So if this light bulb potential difference is a bigger, so for example, 6 volts. So 6 volts light bulb compared to a 2 volts light bulb, a 6 volts light bulb will tell you 6 joules of energy, all right, will be converted from electrical energy into light and heat energy, because light bulb will give out light and heat for each unit of charge passing through the bulb. All right, so each unit of charge means many charges. All right, So this is another meaning of potential difference. Right, let's take a look at question 2.